Good morning. We'll be starting in about 2 minutes. Folks sign in. If you want to download the handout, it's on our website at the address on the screen. We'll be starting up in about 1 minute. For those who are joining us on Facebook Live, remember you can put your questions in via the chat pod, or not chat pod, whatever they call it on Facebook Live. Question and answer. So good morning and welcome to our webinar for a Tuesday here in the lovely month of August. My name is David Orr. I'm the director here at the Cornell Local Roads program, and we'll get my camera so you're not so seeing just the top of my head. Today we're going to be talking about guiderail. For those of you not from New York, New Jersey, and Connecticut, you call it guardrail, but it's the same stuff. It's rails that we're talking about today. And as a reminder, the chat pod has been turned off, but I may ask you to raise your hands now and then, and there will be a Q&A pod that's available. The class is worth 1 professional development hour here in New York State, but again, only the person who's registered will get that. To get that afterwards, we send you a certificate for attendance if you stay for about 3/4 of the session, but if you want a PDH, you need to stay for 90% of the session. Send us your certificate and then we'll send you the PDH. If you're from out of state, you need to get a professional development hour. You'll need to check with your LTAP center in your state before to figure out what you need to do. So before we get into this, I'm going to launch a poll here just to get a sense of who's on the webinar this morning. So if you would please fill that out, just to give me a little bit of sense of who we're talking to today. It helps me quite a bit. How many folks at the site, who you work for, and then scroll on down to the bottom. Make sure you don't miss how long you've been on the job. And if you're wondering how long you've been on the job, NE means new. It's not Mighty Python. Okay, so we're in the polling. We'll share the results. So most of you, again, like we've seen in the past, by yourself. A few of you have 10 or more, hopefully social distance. Over half of you from local government, some states, some consultants, and a couple of folks working for the weekend. If you can figure out what day that is, just let me know. In terms of experience, a little bit more experience than we've seen sometimes. Not as many new folks, but that's okay. Hopefully you'll pick up something and learn something today from this. Okay. Now, when we're talking about the roadside and safety, we're not going to be talking today as much about crash factors and stuff like that we might have in the past. We did a webinar on that earlier this spring, where we talked about the main factors of the vehicle, the highway, and the human factor, and that the human is almost always involved. But there's a lot of things that we can do to improve safety. So I want you to keep that in mind. And when we talk about the rail, it's part of this, but we can think about how humans drive and reduce crashes, even if they never actually take advantage of some of the things that we do. So, something we could spend a lot of time on, we could do a whole webinar on improving places like this particular one that you see here in this photograph. What would you try to do to improve this safety around this particular corner? If you put your answer in the Q&A pod, that would help me get a sense. What do you see in this photograph that could be improved? Realign the road to match the sign. Yeah, that's a good possibility. Or maybe move the sign to match the road. That's a good possibility, yeah. The signage is certainly an issue here. Some delineators could help. A sign facing in the other direction, or if it is an S turn, putting in a proper S-type sign in there. Look at the vertical alignment. That starts to get economically, could get a little bit more expensive. That's a good idea, though. Something to at least think about. Again, the idea is to think about what you can do short-term and long-term. And again, we can spend a whole hour on it, but one of the things that as I go around the state and I see that I really wish people would put a lot more effort on is look at the edges of your roadway. Now we're going to see if our video shows today. I've got several videos of being brave today and see if the internet's going to be happy with me. But this is a test they did where vehicles purposely pulled off the road and then tried to come back on. And you can see it's really hard to control, and you can notice the person goes right into the other lane if they don't crash. It's a real common issue, and actually it can lead to some of the most severe accidents. So one thing I'd like you to think about, long before we think about rail, is think about repairing the edges, your drop-offs, especially on the inside of corners, maybe even widen the pavement out because we know vehicles tend to track, or using the safety edge. We've talked about it in a couple of the webinars we've had this spring. So I really wish we could spend a lot of time on that, but today we're going to be talking about rail. But looking back at that particular photograph, without having to do major realignment, with a lot of extra effort, people mentioned the delineators, actually chevrons possibly needed, proper signage to tell the driver what to really do, and actually really important, might need to be widened here on the inside of this corner, to widen the inside of that sharp corner. It's actually in the green book, it's in the standards, but we don't do it as often as we probably should. But just look how the back end of vehicles, especially those with trailers, track, and try to accommodate that with your pavement. But what we're going to do now, though, is we're actually going to talk about the roadside. So what happens when a vehicle does leave the roadway, and how do we keep them safer? Okay, so I'm going to talk about some of the most common roadway hazards, but again, in the Q&A pod, if you would please, put in an example of a roadside hazard that you think is commonly struck by vehicles when they leave the roadway. Put in some answers for me. A tree, yeah, tree's a good one. Utility poles, signs, blind spots, giant mailbox structures. Yeah, I like that one. Yeah. Guide rail. Yeah, guide rail in of itself is a hazard, and we're going to be talking about that to some extent, okay? Okay, so those are some good answers. Let's go a few of them, talk about a few of them, and talk about their relative hazards that we come up with a little bit. Obviously, trees is a big one. Trees are the most commonly struck roadside hazard. So we want to think about protecting trees. We can't take them all down. We'll talk about why as we go through this hour. But yeah, trees are certainly an issue. But in neither of these two cases have we really done our job. In one case, we put up a rail system that's not really going to protect. And in the second one, we know the tree's been struck, but we're, instead of actually doing something, we're actually just putting up a sign that says, hey, we know there's a problem, but we don't want to remove the tree. And I understand the politics of removing trees, but we just have to be aware of the fact that trees are a deadly fixed hazard when they're hit. We've got to worry about cuts and fills. Certainly, you wouldn't want to go off the left side of this particular roadway, and that particular barrier may not be enough. It's a pretty road, but if people are going out of control, that could be a problem. But even the wall on the inside, if they hit it the wrong place at the wrong time, you got to think about that. We got to worry about slopes. I certainly wouldn't want to take a vehicle off the edge of this slope, and we can talk about things we might do to improve the safety of a slope like this. And what are the economics? We got to worry about people driving to rivers and streams and lakes and bodies of water. They're actually some of the most dangerous things if someone drives into them, or worse yet, they flip over and it doesn't take much depth, and they can be very, very hazardous. So things to think about. One of the people put in there, the mailbox issues. Yep, giant mailbox structures, strong mailbox structures, or even gang mailboxes can be an issue. And so, yeah, we want to make sure we're not putting things in the or alongside the roadway that are going to create problems for us. Now, highway departments and street departments, we put up our own items. We call them appurtenances. It's an engineering term, 5 syllables or more. Remember that. 5 syllables or more is an engineering term. I learned that from John Hopkins, not the school, the individual who ran a center like ours in several states over the years. But signs, poles, and guiderail, if you put these things up, you've actually created the hazards that could affect the driver as they go along. And so think about that and think about whether or not you're putting things in can handle the vehicles that hit them. The goal is to not create something that's actually more dangerous than what was there in the first place. That was just a single small pipe holding up a sign. We want to have breakaway systems for our signs, possibly even for our poles. And we want to put rail up in such a way that it actually doesn't make things less safe, if at all possible. Okay, so keep that in mind as we go forward. Signs certainly are an issue, okay? And if the signpost isn't breakaway or sticks out of the ground too far, it's going to be an issue. So we need to make sure we don't do that. Utility poles are certainly an issue. We can't get rid of all the utility poles. They're there for a reason, but we want to think about where we put them. Make sure we put them in a place that is at least less likely to be struck, or if they are struck, maybe they're not struck at such a high speed. And yes, rail is a hazard, especially rail that's got improper ends or isn't anchored properly, can be certainly a major issue. So think about that as we're thinking about whether we're going to put rail up or not. And when it comes to fixed object crashes, I'm going to give you a list, okay? Trees and shrubs, signs and poles, other fixed, barriers or other fixed. In the Q&A, what do you think is the most commonly struck? What do you think is trees? Trees? Trees. Yeah, I did say earlier, somebody was listening. Yeah. Turns out almost half of all the single vehicle fatal crashes when you leave the roadway are caused by somebody hitting a piece of vegetation, a tree or a large shrub, okay? But signs and poles, they pop up pretty high, 17% still, so that's pretty important. Other fixed objects, the barriers are a danger, about 12% of the fatal. That's when they hit barrier. And then there's other things like slopes and stuff like that that lead to fixed object crashes that are counted that way, okay? And for those who are wondering, it's just as dangerous in an urban setting hitting a tree. The fatals aren't that much less. People go, well, it's all rural, high speed. Well, about a third of all fatal crashes with trees actually occur in urban areas because trees are pretty unforgiving, okay? So one of the things we want to think about when it comes to trees is having good clear zone and basic recovery width. Now, I don't like in a slide deck to put too much in the way of text because I know what's going to happen. You're all going to read it, okay? But this is one that's important enough. I want to put it in. This comes from the AASHTO Roadside Design Guide. And if you didn't get the handout, you can download that handout later on. The Roadside Design Guide defines the clear zone as the unobstructed traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. Okay, so that essentially means everything past the shoulder. Some people define it at the edge of the shoulder. In my mind, think about how wide you want to be able to run off that road and not hit something or drop off so steeply that you can't traverse it. Okay, now, does anybody know what they have that they'd like to see for a clear zone on their particular stretch of highway? What would you like to have? 15 feet? I see a 15 feet. Okay. Well, 15 feet's not uncommon, but has anybody ever heard of a 30-foot clear zone? People talk about a 30-foot clear zone. It's commonly talked about in the literature, and people go, oh yeah, we got to have that. Somebody already knows the answer. They've been reading ahead. Varies depending on traffic count and speed. Very good. The General Motors has a proving ground where they test vehicles out. And they started looking at all their off the road or off the track incidents over a 10-year period. And this is a plot. Now, it's not all the points. It's just a line driven through the points. And they found out that about 80% of the vehicles stayed within 30 feet of the track before they stopped. And so they said, well, 80%, why don't we make 30 feet as what we'd like to see for a clear zone? That sounds really good, except realize, A, people leaving there didn't have to worry about hitting a tree. It's a wide open area. It's a testing track, and they might be driving a little faster than even the people who probably are driving too fast on most of our roads. They're purposely trying to test things. So 30 feet was chosen, but it might have been a little bit too much. Now, in an interstate, can't say that that's necessarily a bad number. Probably is a good number. But we don't necessarily need to have that much clear zone on all of our roadways. And it really does depend on speed, type of roadway, a whole bunch of conditions. So if you look at all the standards and you start reading through the literature, for urban low-speed roads like in a village, how much distance do you think you need for a clear zone in a village or a small residential part of a city? Do you need 30 feet? Could you even get 30 feet? I mean, I have to bulldoze my house. I'm not 30 feet from the road. So what would you like to see for a clear zone in an urban area? 3 feet? Yeah, that's possible. Yeah. Interestingly enough, what actually drives a lot of the clear zone is actually the distance from the edge of the curb face so we don't hit it with our mirrors. So you'll actually see a lot of times 18 inches from the curb face. But obviously, if there's no curbs, like you see in the photograph here, you might even want a little bit more. More is better, okay? But again, 18 inches, 3 feet in the Q&A, that's fine. But the idea is consistency is also pretty important as well. Don't put something that's unexpected, okay? Consistency does actually help. In a rural area where there's higher speed for low volume roads, if you look at the standards again, under 400 vehicles a day, 6 feet is a good typical number that you'll see people use. But that's on straightaways, okay? And obviously, again, more is better. Most local roads, 7 to 10 feet is probably fine. And you want to be consistent about that more than anything else. You start getting into collectors, however, it's going to get larger, 10 up to 30 feet, again, depending upon the traffic volume and other conditions and factors. It does, as was said earlier, depends on the speed and the volume, okay? Now, there's a chart. The AASHTO puts out a chart, the American Association of State and Highway and Transportation Officials, but also New York State has a chart they put into their highway design manual, and you can actually download it off the web. It's on the handout, the link to that. And this is the chart from the handout, and I know what you're thinking right now. You're all thinking the same thing. You're going, Dave, it's too small. I can't read it. It's okay. You don't need to read it. You can download the HDM. It's table 10-1 if you need to look it up. We're not going to get into specific numbers too much, but there are a couple that I do want to talk about a little bit. And it does matter in terms of your clear zone. It matters your slope, it matters your speed, and it matters the traffic volume and even the type of roadway to some extent. So if you pull out from that table and you look at a high speed, our typical state speed limit of 55 miles an hour, and you look at traffic volumes under 750 vehicles a day, if it's a fairly flat slope, 16 feet is what the state recommends on the collectors and arterial system, okay? They don't recommend even worry about clear zone slope, though, if it's steeper than 1-on-3 or even 1-on-3. They want you to do something else, like possibly put in some rail. And on an arterial, that's probably a good thing, but most of us can't get a 1-on-3. But again, it comes down to slope and speed and things like that. Now, in your existing system, I know very few people who are going to be able to get a 22-foot clear zone. It's just not going to happen. So really what you want to think about is for your existing road system, maintain the existing width. Try to improve at problem locations where you know there have been accidents or crashes or concerns. And whenever you do construction, when you do major upgrades, try to improve that clear zone, again, trying to be consistent, okay? So here's a roadway. Any issues here? Do you see any problems here with this particular spot? You can put that in the Q&A pod. Well, yeah, I know you know the answer. You took the picture. Somebody knows the picture. Roadside ditch needs some mowing, vegetation. Most of you, you see the trees over on the right. You don't want to hit the trees on the right, so you go to the left, right? I wouldn't go to the left here. That's a blow up of the picture. What do you notice now? Some stumps. And that's very, very deadly. One of the worst things we can possibly do is when we cut down trees, we leave the stumps. You really want to cut them flush or remove the stump completely. Grinding it flush is actually fine, but don't leave a stump like that. That's actually one of the most dangerous things you could possibly do, because now you don't even notice it until it's too late. So first question for the day that we'll have, I'm not doing poll on this, so it's okay. Just answer the question, what is the proper clear zone on a highway? You should be able to answer that now. What is the proper clear zone on a highway? 6 feet, possibly on the local road, yeah? Depends on the situation, yeah? It depends. It depends on your speed, depends on your slope, depends on your traffic. And you probably should think about setting up policy for this, okay? And yeah, I want the answer in the Q&A pod. I'll let you know if there's going to be a poll question or something other than the Q&A pod, or ask you to raise your hands, okay? Now, one thing, please think about this. Clear zones, we want to be consistent, but think about increasing your clear zone on your curves, okay? The sharper the curve, the more you want to increase that clear zone, because the more chances someone's going to go off and hit something, okay? So extend it out. There are places on the interstate system where they've got 30-foot of clear zone, and yet it's very deadly because it's on the outside of a corner and people drive straight into the fixed object. So think about making it wider. It also improves, by the way, sunlight on the curve. There's a lot of good reasons to do that, but think about improving, especially on sharp curves. But now we're worried about, okay, vehicles have left the road. We've done the best we can do on the clear zone. What are we going to do about treatments? We're going to actually start talking about rails. And you'll notice, if you look at the list of options, that rails don't start at the top of the list. Rails are one of the last things we look at. We want to remove any hazards. We want to make them traversable. We want to relocate them away from the spot where they could get hit. If we have to leave them in the clear zone, we make them crash worthy. Then and only then do we shield them with some kind of rail system. And finally, we delineate. And there are actually times where actually you would flip the order and you would delineate first. And we'll talk about that a little bit, okay? So the first thing that obviously would be best if you could do it is to remove the hazard. This is a site that used to have a ditch, and they just filled the ditch in with a pipe, and now it's flat, it's traversable. You've removed the hazard. There is no longer something to be struck within the clear zone. Obviously, there's some cost involved, but if you can do that, that's really cool. The second choice is make it traversable if at all possible. And putting in either the special pipe systems like you see on the right, or the number 8 1-inch diameter rebar on a 1-foot grid, which you'll see on the left, both are very effective, okay? And the key here is they're not designed in this case to stop flow. In fact, they're actually bad in the case of flow. You want to be able to yank them out in a flooding event, but you want to be able to get to them. In this particular case, those rocks that are in front of the pipe may actually make it not possible to get to where that pipe is. So think about, be careful if you're thinking something's traversable. Now, someone put into the Q&A pod a good question. They said they've worked on projects where they justified trees in the clear zone because they were looked on as traffic calming. If you want to have a traffic calming policy and trees are part of that, you have to be aware of the fact that you've actually left a hazard in there, and that's a balancing act. Trees do actually slow people down. There's some good research that shows that. But if the tree is not in a good location and gets struck, you actually have gone backwards from what you were trying to do. Some consistency, curbs, gutters, things like that can helpful, but be careful with trees. They are very deadly when they get struck. So I would be careful about that, leaving them up and justifying them as traffic calming. They can be part of an overall program, but be very careful with that. Now, this is a location where it looks like they've got a pretty good clear zone, but you'll notice in the distance, you can actually see 6 crosses. There was a crash here. Multiple people were killed. This is on an interstate. And it doesn't look like much, but that little drop off from that culvert right there was enough to when someone hit it, they rolled and 6 people were killed. So a clear zone isn't clear if you can't traverse the whole section of the clear zone. But a bigger problem on most of our local systems are our ditches. And it doesn't take much. If it's not consistent, if it's not smooth and someone drops into that, it can be very, very dangerous. In this case, it's not much of a ditch. And yet when they hit it, they had all kinds of problems and rolled the vehicle. So try to think about a smoother transition if at all possible. And somebody did ask, and I'll go back real quickly. They asked about clogging of the grates. Yeah, these grates that you'll see, these special ends, they're not designed to stop clogging. So you're going to be able to yank them out when an event occurs. Their job is to reduce the need to put rail up, okay? One thing we can do, we don't do it probably enough, is to relocate the hazard, move it out of the danger zone, get it further and further away from the roadway. If it's too close, it's more likely to be struck. There's actually data out there. If you're interested and you'd like this is actually from a National Cooperative Highway Research Program, or NCHRP. It's 440, it's on the web. It's also in NCHRP 500. But it shows the crash reduction by relocating the hazard. So if you could move the trees back just 3 feet, you drop the crash rate by about 22%. If you could move it 10 feet, you can cut it by 2/3, which is why it's so valuable to look at getting the trees further back if at all possible. Even removing your mailboxes and your signs can reduce the crashes because they're less likely to get struck. And rail, interestingly enough, you put the rail where it belongs. Put it up when you need it, but put it up properly. You can actually reduce the crash rate. Okay, so moving things back can make a huge difference. But do me a favor, when you move them back, think very carefully. Does anybody notice a problem with this particular utility pole and its location? And while I'm waiting for an answer there, someone asked, do signs saying no shoulder work? They work in the short term. Signs like no shoulder, you might see them for about 5 or 10 passes, but eventually they stop working. They should only be a temporary. A no shoulder is really just a warning that something has changed. I wouldn't make that a permanent issue because people will stop seeing it after a while. Yeah. Yep, everybody's getting it. The sign, the utility pole in this case, is right in the bottom line of the ditch. You don't want to put something in what is known as the traversable way of the ditch, because that's where the vehicle, if it goes off this road, is going to wind up going. And if it's got any speed, it's going to stay in that ditch line. And by putting the utility pole in the ditch line, you've actually made it almost more hazardous than if it were up closer to the roadway. So when you think about where utility poles are, try to avoid any place where a vehicle could be going down that ditch because it goes off the roadway for whatever reason, okay? So in this case, I'd actually want it further over to the Kritz Farm sign there. You can make things crash worthy. Mailboxes, you know, we put them in our road system, but we can make them more crash worthy. They're not the big brick things that are out there, okay? And there are designs that are designed to flop over the top of the vehicle, get crushed straight down, but you can make them crash worthy. And that's not just the case of our mailboxes. Our signs as well, we can do the same thing, okay? Now, this is something, the 4-inch rule. Anything above 4 inches that can snag a vehicle or stop a vehicle is considered a fixed object. 4 inches isn't very tall, but that's essentially the amount of ground clearance you'd have on a small car. And in some of the videos that we could show to you, a small vehicle can get snagged and it can be just as deadly as hitting a big, tall object, okay? So 4 inches, think about that. And someone says, what about drainage ditches as a roadside hazard? Yeah, they're an issue. We'll actually talk about them a little bit more, but yeah, drainage ditches are an issue. And utility poles, yeah, it's difficult. And especially because right-of-ways in this state, or a lot of them are roads by use, it can be very difficult to figure out exactly where the right-of-way is in some cases. But do me a favor, if you're going to put in signs, especially in the clear zone, make sure they either break away or the parts that aren't breakaway are down below the 4 inches. Okay, like a number 3 post, that's considered crash worthy. But anything heavier than that, you need to have a ground post and a proper connector. In this particular case, that connector connecting those 2 channels cost 25 cents. It's pretty cheap insurance. So now we're going to talk about shielding. Well, actually, we're going to talk about shielding a little bit more in a minute. But notice I'm all the way down the list to almost to the end, and now I'm talking about shielding. Shielding is one of the last things we do because, as we talked earlier, it's about 12% of fatal crashes involve hitting rail. So we can put shielding up, put up our rail, but we want to do it properly, okay? And then lastly, we delineate. In fact, if you're not sure in the short term, delineate. Put some delineation up, watch it for a while until you can come back in and do something else. Relocate, put up your rail. I always like to start with some kind of delineation. It's not a bad idea. In fact, there was actually some pretty good evidence out there that on really low volume roads, under 400 vehicles a day, it's actually probably more economical and actually more likely to actually cause some severe crashes to sometimes delineate first and put up shielding or rail last. Now, it depends what you're trying to protect. In this particular case, this is a pretty steep slope. So maybe this is a case whereby you could think about putting up rail. But on the other hand, I happen to know in this particular case, the traffic volume is under 20 vehicles a day. So as a minimum, let's put up some delineation. Okay, delineate the edge of this. Just some simple delineators. You can lollipop them or not, that's up to you. Okay, so start with that. So in the Q&A pod, let's see how we do. What are the steps for dealing with roadside hazards? There's 6 of them. See if y'all can get, anybody can get all 6 of them here. I know I'm making you type early in the morning without too much coffee. Identify your problem. That's probably a good point. That's the first thing, is to identify what are your issues. Yeah, that's actually a pretty good point. Yeah. Remove, make traversable, relocate, make crashworthy, shield, and delineate. Very good. Okay. And by the way, it's in the handout. You don't have to remember it, but I just want you to think about the fact that rail is valuable, but it's really towards the end after you've looked at everything else. Okay. So now I want to spend most of the rest of the time talking about choosing the correct guide rail. Okay. And if you're from out of, again, here in the Northeast, you can call it guardrail if you prefer. Okay. But I want to make sure you choose the right system. Okay. Jeff Scott, our technical systems engineer, he sent me this photograph. This rail is really probably not doing the job, and we'll talk about why. But when we talk about guide rail, we want to make sure we have the right type of guide rail. So there's lots of different types. We have to worry about the deflection of the rail system. That's actually very important. There's something called the point of need. We'll talk a little bit about that. The runout length, especially if you've got bodies of water or things you don't want someone driving into behind the rail system. And then the end sections themselves, okay? Before we get started though, I want you to realize what rail is. Most people think of rail as a barrier. In fact, that's how the term guide rail got going on here in New York, because it doesn't really guard things, it guides vehicles. It's just rail though, that's a nuance more than anything else. But how does it work? Well, it's actually like a big rubber band. Okay, watch the truck when it hits. It's a cable system, but it deflects it, brings it back in. It's like a big rubber band to hold the vehicle in. I've got some videos of buses. It's amazing. If it's installed properly, it'll actually let a vehicle go out and pull it right back in. So it's got to have a good end. It's got to be able to build that tension into the system. And if it has that, it works pretty darn well. And the rule of thumb is use the lightest rail system to do the job, because there's less damage put back into the vehicle if you have a light rail system, okay? So what are the common rail types? Well, I'll show you some pictures of some of them, but cable, of course, is the lightest. Then we have weak W-beam. We have box beam, which we'll use a lot of here in New York. Heavy post, blocked out W-beam. You could use tri-rail, concrete half sections. There's lots of different rail types that exist out there, okay? And again, you need to think about both the lightest you can put in, but can you maintain them? I like cable rail. Cable rail's aesthetically pretty pleasing. It doesn't interfere much with your viewscape, but you've got to maintain it. There's a turnbuckle system. It's got to have the proper tension. You need all three cables to have about the same amount of tension in them, or they're not really going to do the job as well as you'd like. But cable's a common system and can actually be used against slopes if it's got the right connections to the post. Okay. You can use weak W beams. Okay. I like that. Also, again, it's a fairly light system, but it's got to have enough links to build up that tension to act like that big rubber band. Otherwise, it's not really doing the job we want it to do. And it's got to have enough deflection. And we'll come back to that in a little bit. There's box beam. Again, we use a lot of box beam here in New York State. Box beam is nice. It actually transitions into bridge rail pretty easily. You know, people like it. Relatively easy to maintain. Okay. But again, it's a little stiffer than the W rail system. You can block things out with plastic or wooden blocks and heavy post beams. Now, this particular picture shows the aftermath of someone actually going through the end of the rail system. You've got to have good end sections, whatever rail system you've got. Okay. Now, the next thing I'm going to show you is a video of a newer system called MGS. It's a modified guide rail system tested to the most current AASHTO standards. And we can get you the details for this, but just want you to see what happens when a truck hits. Okay? And you can see it actually worked pretty darn well. The blockout system, it hits it pretty hard. Watch it coming in slowly. Okay? The whole point of the blockouts is to give it a little bit of space so it doesn't snag on the post. Okay? And it does a pretty good job. It does snag right there. You can see a little bit of snagging. But for the most part, that vehicle is almost in midair and is being pulled back by that rubber band effect. And it hit it at a pretty sharp angle. But again, the rail did its job. And watch what happens when a smaller car hits it. Okay? Yeah, a little more damage to the car, but the driver could walk away from that. And that's really the goal in this particular case. Watch high speed. Okay? The damage was because it did a little bit of snagging. But again, it did an amazing job of protecting. Okay? The key is use the lightest rail system you can possibly use. You can use it up against slopes, but if you do that, make sure you've got good soil support, because that post system has to have that support to hold it in the right elevation, but also to help continue that tension along the system. Okay? Otherwise, it doesn't deflect properly. Now, finally, you could go with a concrete half section, Jersey barrier, it's sometimes called, K-rail, you'll hear. That has zero deflection, which is good on a causeway or a bridgeway like this, but be aware of the fact that when someone hits it, it's hitting a fixed object to some extent. So just be aware, it's not used real commonly on the local road system, okay? Now, what's the deflection distance? Well, that's a pretty important characteristic. You've really had to have a good deflection distance. So I'm going to flip over here to the handout. Okay, I know it's here somewhere. I had it open up, I went right by it. Okay, so this is the handout. You'll be able to look at that deflection distance later on. Okay, so I'm going to scroll down here. And in the handout, you'll actually see a table. This is pulled from the New York State's quick reference sheet. Okay, and it shows for the different types of barrier what the deflections are. Okay, so you can see, given on depending on how stiff it is, how much deflection it's going to need behind the system. Now, why is that important? Well, let's go back over here to our slide deck and watch again the same video we saw before. Watch how much distance that vehicle goes down the roadway. Okay, I'm going to do this one more time. I'm going to stop it. That truck has deflected all the way out, more than the width of that particular truck. Okay, if there is an object within that deflection distance and it hits the rail, it's actually going to be directed into that particular object. Okay, so in this particular case, this W rail that's up, if someone actually hits that rail system upstream of this tree, they're actually going to be directed into the tree. They have no choice. Okay, so you never want anything inside that deflection distance that's a fixed object. So you need to remove any trees, you need to remove heavy shrubs Don't let utility poles be inside that deflection distance. Okay, so the question then comes, which rail systems have a deflection of less than 5 feet? Okay, so I'm going to go back over to the chart and let's go look at the sheet. Which ones have a deflection of less than 5 feet? You can put it in the Q&A pod while I find the ones on here. Let me see if I can get my pen to work here. While y'all give me, here we go, comments. Okay. And I'm going to highlight less than 5 feet. No cable systems have it. 5 are equal, the corrugated with a light post spacing here. Oh, you're not working for me right now. Okay. Box beam, 3-foot spacing. Box, heavy with a block out. Yep. Okay. Jersey barrier. Okay. There are different systems out there. Again, you can look them up in the table. So if we looked at that, systems with less than 5 feet, there's really weak post, very tight spacing. Box beam, heavy post with blockouts, and then concrete. Okay, you're getting some pretty hefty systems when you start doing that, and you got to look at your post spacing. That does make a big difference because, for instance, if we look at the corrugated system with weak post, you put a standard 12-foot 6-inch spacing, you're going to have way too much deflection. Okay. Now, in the charts, in the books, you're going to come across some tables. One of them is called a deflection reduction factor chart, which allows you to reduce the amount of needed deflection. Okay. If we look at, say, for instance, 55 miles an hour, and your lateral offset essentially is how much distance can that vehicle be away from the face of the rail before it swings over and hits it, i.e., how much distance from the other lane over to the rail system. And some people could argue, well, on a fairly narrow town or county road, I could get down in here in the, let me get a pen color we can read here. There we go. I could get down to here and reduce the deflection, you know, down to 80% or something like that if it's a fairly narrow roadway. 80% of 5 feet is still only 4. Most of the time on high-speed roadways, I wouldn't even bother. It's not worth the risk. Only when you start getting into urban areas where it's really low speed do I think you can gain some from taking advantage of these deflection reduction factors. It's much easier. Just keep things out of the space behind it. Because again, that's designed for a car. What happens if a big truck hits it? It's going to deflect more. So give yourself room for the deflection. Okay. And a note here in the pod that says I've seen some awful motorcycle accidents on cable systems. Are all systems equally bad for motorcycles? Actually, a properly set up cable system where all 3 strands are about the same tension isn't actually that bad on the motorcycle. The problem is if there's any slight variations, it can do some real damage. And by the way, it can flip a car. So the idea being, be very careful with maintenance with any system. And what is the maximum left lateral offset? That essentially, if you think about it this way, I'll tell you what, I'm going to go over to my point of need picture. We'll talk about point of need here. That essentially, if you imagine you've got a roadway here and I've got a vehicle in the far lane, way over here, and he's going the other direction, is the distance he would traverse from here all the way over to that point. So if you had a roadway that was 30 feet wide, including your shoulders, the lateral offset would be in the 24 foot range, depending on the width of the vehicle. That's where that comes from. But let's talk about that point of need. Most rail systems I see are too short, okay? And so they just don't have enough distance. If you've got a fixed object behind your rail system, you can't start your rail right here where the first fixed object is. You have to come back so that if a vehicle hits the rail system or doesn't hit the rail system because it hasn't started yet, it doesn't wind up hitting the fixed object. See, it's called the point of need. Now, again, don't try to read this. It's too small, okay? It's in your handout. You can look at it later on. But an easier way to think about this is there's a formula, okay? It's the distance that you need to have from the front of the rail to the back of the object, R, times the cotangent of 15 degrees. Does anybody know what the cotangent of 15 degrees is? It's a hard number to remember. Just remember 4 times R. So essentially 4 times the distance from the front of the rail to the back of the object. So if we go back to our picture we had of our W rail that we saw that we know was too short, and we measure from the front of the rail system all the way to the back of the object, and if it's 7 feet, how much distance do I need to be down the road when I start my rail system? Okay, 28 feet, exactly. 4 times 7. Now, if you do the actual math, it turns out to be 26.2. 28, okay? 28 feet to the beginning of the full rail system, but then you're going to need to add an end section on the end of that. That's to the beginning of the full rail system and into your end section. We'll talk about end sections here in a few minutes. The other item is something called the run out length, okay? Now, in this particular case, you're not worried about someone getting in and hitting a fixed object. You're worried about them going off the edge of the slope. If it's a slope or a water body, you actually want the rail to come back further, because what you're really worried about is somebody sneaking in behind the rail, driving down along beside it, and hitting the body of water. Now, obviously, if there's a steep slope or a lot of trees, they're not going to be able to get there. But if you've got a body of water and fields and flat area, it's something to be aware of, to think about. So you may come further out, and especially you see this on the interstate system. And the run out length is based mostly on speed in this particular case. And so for most of our roads at 55 miles an hour, we're talking about 260 feet. So if a vehicle gets behind it, it has time to stop. Okay. Now, is it applicable everywhere? No. Okay. But it's something to think about. Now, if you can't get past it, that's something to think about, like a stream like this. You certainly don't want someone getting in behind here and driving into the stream. That would be a problem, okay? But it's a very low volume road. Is it worth it? It's a balancing act. You're gonna have to look at that. But in this particular case, if you wanted to do a run out distance, you would have to come 165 feet from the edge of the stream. So that might define the beginning of your rail system more than the point of need, okay? Just something to be aware of. Just keep that in mind as you're putting up your system. But what I want to make sure we are aware of is the end section issue. I see this way too often, and that is the end sections don't really do the job they're supposed to do, okay? That picture we saw earlier of that SUV that had been split by the rail, scary. And a lot of that is because the end sections aren't doing their job. They're acting more like spears than anything else. So you really want to have good end sections. And there's 4 or 5 things we can do. The most common that we used to use for a long time was to anchor into the back slope if at all possible. And that's actually a good technique. You bring it all the way over into the back slope. That way if the vehicle gets off, it's not hitting any rail system. The danger is if this distance here with the rail is too tall, a vehicle can actually get under that rail and submerge, and it can actually be more dangerous. So be aware of that fact. There's a maximum height. In this case, you're exceeding it by a little bit. You may actually need to put a pipe section in there so that if somebody hits it, they're actually at the proper height, okay? You can also just sweep it out of the clear zone. In some respects, it's not that much difference than putting it into the bank, okay? And this is by far the most common you see with the box beam system, because you really don't want to go off the end of that rail right there. But that can be very effective if you get it past the clear zone. And the key, of course, is to make sure you have enough displacement distance for the fixed objects, okay? And there probably is enough distance, for instance, for that utility pole. I'm not sure about that fire hydrant. I would want to make sure that fire hydrant is designed as the type that can be hit. Not all fire hydrants are frangible and can be struck. Okay, rustic rail. Yep, well, it works in the right conditions. Be careful if it's too humid; it can actually rust even faster. You can turn down the ends. Okay. Generally, we should only be turning down the ends either in low speed situations or at the end of rail systems when they can't be struck from the other side, i.e. parkways, interstates. We're not going to use them on the 2-lane roads unless we can get them further off the roadway. They're risky. And why are they risky? Well, I'm going to show you a video. I get to hear the silly music behind it. You get to watch the video. I purposely didn't turn on the sound because the music is really odd. But watch carefully as the vehicle hits the end of this rail system, this turn down. And there's lots of videos of turn downs. And here he goes. Whoop. He vaults over the end. Okay. The end of that system can be very dangerous because it can actually launch the vehicle into the air. Okay. So it's something to be aware of. You want to be very careful with the turn down ends. What we use instead these days are crash-worthy terminals. Okay. There's lots of crash-worthy terminals that exist out there. They're available. Every state's got its own specs that it's approved. Okay. When you put these things in, essentially what's happening is there's a cable or a system where these last couple of posts are held together. Okay. And the tension of the system is set up so that if you strike it just past this second post, that delineator in this case, this post here, it's got full tension. It can act just like the rubber band feature that we want, but it's also set up that if you hit it at the side, not on the end, on the side, it's supposed to fail and push out of the way, so it doesn't cause it to crash too badly. And if you hit the very end, it's designed to crumple in different ways. Okay, so the point of need in this particular case is essentially that point where the system starts. And every system has its own system set up. But watch carefully this video here. Watch when the truck comes by, okay? And you can see how the rail system actually essentially acts as an anchor. It's an anchor in the middle of the air, and it works pretty well, okay? But make sure you install them properly, and if it has a turnbuckle system, that you go back and you do the maintenance on it to keep it in good shape, okay? And here's, of course, what happens if you haven't done your job properly of anchoring, your bolts are not put in properly, okay? You need that end anchor section. You've got to have it done properly, okay? It didn't contain the vehicle. It went right on through, okay? Not good. So if you're going to put them in properly. They're really valuable, but again, choose the right end section and install it properly. Some other concerns with rail systems, be very, very wary of where you put them with respect to sidewalks, because a curb system can actually cause the vehicle to start a vault. And then of course, when it hits the rail, it's going to keep going right over the top. So think about that. You may want to make your rail slightly higher, or better yet, it's interestingly enough, you might want to actually put the rail closer. Now, I know in this case it's a sidewalk, but there are some rules about how to do that. And again, you can look in the Highway Design Manual for that information. The other one I see way too often is the bridge approach rail. We got to do a good job. It needs to transition from being the strength of the rail, no deflection, to lighter, which is typical. Watch the end of that car when it hits the concrete. The rail system has actually deflected it right into the end of the bridge itself. Okay, it's actually made it more dangerous than if it wasn't there in the first place. Okay. And my system has decided to go freezing. Let's try waiting for it for a second here. I may have to restart. I don't know why it's decided to do that right now. We're going to close the program and restart. So you'll get to see my background screen. I don't know what my background screen is right now. But think about that when you're putting in your bridge rail systems. Do me a favor and think real carefully about that, okay? More than anything else, I really don't want you to have a situation where someone is actually worse off because they hit the rail than anything else. So keep that in mind, okay? So I'm going to restart my PowerPoint here. When I say zero deflection to wider, zero deflection to more deflection. So most rail systems we saw have a deflection ratio, you can see it on the screen here, anywhere from 2 to 5 feet, right? Okay. And up to 11 feet for a cable system. Well, if you had a cable system with 11 feet of deflection, the bridge typically has zero deflection. We need to transition in this particular case. Otherwise, we'll get ourselves into trouble. And so that's something to be aware of, okay? And so we'll go in here. Yay, our system is working again. And we'll come down here. And this is what I'm talking about. You want to gradually increase the stiffness. So you might start with a W rail system, transition it to a heavy post system, and then double the strength up or even put a channel section behind it, you can actually see the secondary rail sticking out here near the bottom of the rail system. You want to transition. There's lots of standards out available. You don't have to reinvent the wheel, okay? But remember, it's going to take you about 25 feet to go from a 3-foot deflection down to 0 and another 25 feet to get to 6 feet. So it could be 40, 50, 60 feet to be able to get enough transition, okay? As you're doing your work, update and replace. Rail has a minimum height and a maximum height to do the job properly. In this case, high-speed roadway, I could be wrong, but I don't think they have enough height here. And in fact, if anything, if a vehicle hits that rail system, it's going to actually make it worse because now a vehicle could go right over it and actually be out of control when it hits. So this is just overlays. Literally over time, they just overlaid this road until the rail system is no longer doing the job. You need to make sure you check behind the rail system. Again, it's a small culvert, but there's no support on those posts. And so if someone hits it, it doesn't do the job like it's supposed to do. And as you go around, Jeff and I find all kinds of fun stuff. Jeff sent this picture to me. There's a single strand of cable, so it's not really rail by anybody's definition. And I'm not sure. I don't think that's a proper anchor. I could be wrong, but I don't think so. So again, maintain things, put them all up. So what we're going to do now is we're going to end with putting it all together. I'm going to show you some photographs, okay? I have about 6, but because my computer decided to freeze up, I'll probably show you 5. Want you to choose from the list, and I'll actually start a poll so you don't have to remember the choices, okay? So I'll let you choose: remove, make traversable, relocate, make crashworthy, shield, delineate, or maybe even do nothing, okay? So let's start with our first one, and I'll start the poll. On that particular site, would you remove, make traversable, relocate, make crashworthy, shield, delineate, or do nothing? And for those who don't remember, it's a really low volume roadway. I'd like to get to at least 2/3 of you. Almost there. Okay, that's good. I'll end the polling. I'll share the results. Yeah, about 2/3 of you said delineate. About 22 said shield. Yeah. And yeah, those are probably the right choices. If it were higher speed, I'd be thinking about shielding, a higher volume, excuse me. But low volume, at least delineate, and then you can think about shielding. Remember, if you're going to start putting rail up in one part of your municipality, you really want to have a plan for the whole municipality because you could expose yourself to liability otherwise, okay? I'd love to be able to make that transversable, but that's a 40-foot drop down to the stream, so that could be difficult. But hey, what the heck? Okay, let's go with the next one here. Okay, and I'm going to relaunch the polling. And let's see what y'all think. This culvert section, are you going to remove it, make it traversable, relocate, make crashworthy, shield, delineate, or do nothing? It's a little more challenging in this case. Again, I'll wait till I get at least half of you. Okay. I'm going to end the polling. I'm going to share the results. Now, some of you said remove, but remember the driveway's still there. So it's going to be very hard to remove it unless you, again, like we saw in the photograph, fill that in with pipe on each side, a long distance away to remove it. And that is a possibility looking at economics. You could make it traversable. They make sections for the end of the pipe system. They could make it traversable. Again, it comes back to economics. You obviously can't relocate it completely. Make it crashworthy is a form of making it traversable, but in this particular case, it'd be hard to do. You could shield it. The problem with trying to shield driveway entrances is you don't have enough length for your transitions and your intersections. So a lot of times when we put these breaks like box beam along lake roads, it actually is a bit of a challenge because you're not really able to get that full tensioning that you'd really like to have. And it's actually a known problem. And yes, you should delineate. And in the long run, it's certainly something I would think about doing, is at least delineating short term so I can do something longer term. Also might make it easier for the person to see their driveway. Okay. Okay, I'll relaunch the polling. Look at this bridge section. Here's a light, heavy post rail, no blockouts, coming up to a bridge. So what are you going to do? Remove, make traversable, make crashworthy, shield, delineate, do nothing. Okay. And I'll get to at least half of you voting here. It's a little bit more challenging because it doesn't fit quite into the nice list. Okay. And so most of you said make crashworthy. Essentially, you're going to have the shields already there. You're not going to get rid of that rail system. So you at least need to make that rail system installed properly. So yeah, make crashworthy is probably the right word set to use. But the goal is to transition from a light system, whatever you need because of the slope or what's alongside the roadway, into the zero deflection of the bridge itself. And you got to tie those two together. Otherwise, you could actually make the problems worse than if you'd had no rail system at all. Okay. I got another one that's actually more common. I see this all over the state. And then I got one more after that. We'll call it a day. Okay. So I'll relaunch the polling. What would you do here? Okay. Polling's up. You're going to remove that, make it traversable, relocate, make crashworthy, shield, delineate, or do nothing. Wow, maps all over the map here. I'll end the polling and share the results with you. Okay. All over the place. Okay. Removing is a minimum. You want to think about that wall. That big concrete wall is dangerous. If you could remove it and somehow flatten the slope so that people going off didn't crash into the stream, that actually might be optimum, making it traversable to some extent. Making it crashworthy or shielding it by putting in a proper transition rail system, that could work as well. Both of those could cost a bit of money. Maybe in the short term you delineate it. The key is make sure you think about what you can do short term and long term. I don't want to leave those concrete walls up. Delineating it only on a low volume road would be something I'd leave up because that's a fixed object that when someone hits it, they stop. Okay. And I got one last one. To me, this is one of the ones that I see this, and I want you to just think about this. What would you do in this particular case? This is a pretty good situation. Okay. So I've restarted the polling. Are you going to remove it, make traversable, relocate, make crashworthy, shield, delineate, or do nothing? Okay. It's a little more challenging. Okay. I'm going to end the polling. I'm going to share the results. A lot of you said remove. You could make it traversable. I'm going to hide I'm going to move the results out of the way. I'm going to stop showing them for a second. And I want to show you what you're actually protecting. It's a small little section. Okay. It's not long enough. It's not really protecting that much. In terms of protecting the pedestrians in the area, delineation is probably what you need to protect them. Yeah, removing is probably a good thing to start thinking about, okay, that a lot of you said. Now, one person asked, what about delineating rail? Absolutely a good idea. That's actually a great thing to think about doing. I'm not going to do the poll question here just because of time. But there's a good example. There's a rail system where once the tree is removed, and by the way, it was struck a few months after the photograph was taken, but the tree had been removed, so the person was not killed. But yeah, you can put delineators either on top of the post, or they actually make ones that fit inside the W rail. Delineating rail is actually a great thing to do because also it's protected from damage. So keep that in mind. Just think about roadside safety. Think about your mailboxes. Are they crashworthy? Think about your ditches. Make sure they're traversable, okay? Be safe out there, okay?